So in this, we're gonna talk about molar solubility. So all ionic compounds dissolve in water to some degree. We can apply concepts of equilibrium to salts dissolving. The equilibrium constant for the dissociation of solid salt into its aqueous ion is called solubility product. So that is KSP. For example, we have our silver chloride salt, which is solid, and when it undergoes dissociation, when it dissolves in water, it forms silver ion, aqueous, and chloride ion. So we can write the solubility product of water as this KSP, which is going to be the concentration of the silver ion and the chloride ion. Remember, because this is aqueous and aqueous, we include them in the equilibrium constant expression. We do not add solid, right? So molar solubility is what we want to look at right now. So solubility is the amount of solid that will dissolve in a given amount of solution. The molar solubility is the number of moles of solute that will dissolve in 1 liter solution. So we are going to consider the molar solubility, and because molar solubility is related to KSP. So we have precipitation that can occur, right? Precipitation will occur when concentration of ions exceed the solubility of the ionic compound. So we can compare the reaction with the reaction quotient. We can compare this KSP to the reaction quotient, and we can use that to determine if precipitation will occur. I use this for precipitation. So when Q, which is the reaction quotient, is equal to KSP, so there is no precipitation, because the solution is saturated. When Q is less than KSP, there is no precipitation. Solution at this point is unsaturated. So when Q is greater than KSP, solution is above saturation, and salt will form precipitates. So let's take an example. Calculate the molar solubility of lead 2 chloride in pure water. So the KSP is given to us as 1.17 times 10 to negative 5. So as usual, we can write for lead 2 chloride solid, it dissociates into lead 2 ion, aqueous, and 2 chloride ions. So we can write the KSP for this equation to be the concentration of the lead ion into the concentration of the chloride raised to power 2, because we have this 2 here. Again, we're going to construct our ICE table for this. So initially, this is 0, the concentration, and the change is going to be, because remember, these are products, right? Products are all positive. These are reactants. We do not include this, so that is why we do not have anything on the reactant side. So this is going to be positive S, and this is going to be 2S, positive 2S, because we have 2 chloride ions, right? So we can find the equilibrium concentration. So this is going to be S, and this is going to be 2S. So we substitute that into our KSP. So for lead, it is S, and for chloride ion, it is 2S. And we have this 2 here, we place it here. So our KSP is going to be 4S cubed, right? because this is gonna be S into 4S squared, right? When you open this. All right, so our KSP is going to be 4 times S raised to power 3. And remember, the question is asking us for the molar solubility of lead 2 chloride. Our molar solubility is our S, right? So our S is gonna be S cube is gonna be KSP over 4. And of course, we are looking for S, not S cube. So our S is gonna be the cube root of KSP over 4. And in this case, we know that our KSP is 1 point. It's going to be cube root of 1.17 times 10 to negative 5 over 4. When we plug this into our calculator, it's going to give us 1.43 times 10 to negative 2 molar. So that is going to be the solubility of our lead 2 chloride. So we can also find for another example that we can take a look at is this, the molar solubility for silver nitrate in pure water. Let's find the molar solubility for silver nitrate, silver sulfate, Ag2SO4, in pure water. And this is the molar solubility of silver sulfate in pure water is 1.4 times 10 to negative 2 molar. So in this case, we want to calculate KSP. Molar solubility is 1.4 times 10 raised to power negative 2 molar. So we want to find KSP. As usual, the first thing we need to do is to write the equation for this. This is solid and it goes into 2 silver ion plus our sulfate. This is aqueous and this is aqueous. Again, we write our ICE table. So we only need to write for silver and for sulfate ion. So of course this is 0 at 0. We have 2s here, 2s, and this is positive and this is positive. So we can find the equilibrium, which is going to be 2s, and this is going to be s. So our KSP can be written as Ag plus raised to power 2 and SO4 to negative. So our silver is 2s, so we have 2s squared, and this is s here. So this gives us also 4s cubed, and that is our KSP. So the question is asking for KSP, right? So, and we already have our molar solubility to be 1.4 So we now plug this in here. So we have 4 times 4 into 1.4 times 10 to negative 2 raised to power 3. When we plug this into our calculator, it's going to give us 1.1 times 10 to negative 5. That is the KSP for our silver. So this is how we solve problems that involves uh, molar solubility and KSP. I hope this is going to help us to solve as many problems as we can lay our hands on. Thank you.